Yo, 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 what's up, Mr. White? It's your boy KP.
Hello again, hello. This is 7.5 exponential and log functions. Let's go. We need to solve. If we have a log form, we need to write it exponential, and that might make it a little easier to find the answer. So on the first one, if we take log base 3x equals 4, okay, we can write this as 3 to the 4th power equals x. Well, we know that 3 to the 4th power equals 81, so 81 equals x. On the next one, if we have log, we're going to write 16, because 16 is the base. The exponent is the negative 3/2, which equals x. The negative tells us reciprocal, so the reciprocal of 16 is 1 over 16, and we're going to raise this whole thing still to the 3/2. 1 to the 3/2 is still 1. We can take the square root of 16, which is 4. 4 cubed is 64. Now just remember, it's 1 over, so the answer is 1 over 64. C, base is x. It's 1/3 equals 5. Okay, we need to find the base. We have it to a power. If you remember, the way to solve is raise this to the reciprocal power. So raise it to the third. Raise it to the third. The answer is x equals 125. If we have a to the x equals a to the y, this is true if and only if y and x are equal. So to rewrite both sides as powers, we need to do that by using the original bases. Quick one, we're going to jump to letter E quickly. If we take this log and rewrite it with the base, 2 to the x equals 8 times radical 2. Let's rewrite it with a base of 2. So this is 2 to the x. 8 is 2 to the 3rd times, let's just rewrite the radical as 2 to the 1/2. And what you'll notice, if you have the bases the same, we are adding exponents. So this is 2 to the x equals 2 to the 3 plus 1/2. So 2 to the x equals 2 to the 3.5. So therefore x equals 3.5. Hit pause. Do letters D and F. Check back with me in 1 minute. Welcome back. If you notice D, we wrote 4 to the x power equals 64. 64 is a power of 4, so 4 to the x should equal 4 to the 3rd. Therefore, bases are the same. X equals 3. And on F, 27 and 81, the only thing that they have in common is they are powers of 3. So let's change the bases to 3. So if you notice, this 27 is 3 to the 3rd raised to the 3x. And the 81 is just 3 to the 4th. Power to power, so this 3 times 3 gives you the 9x. So this is 3 to the 9x equals 3 to the 4th. Therefore, because this and this are equal, now we can say that the exponents are equal. So x equals 4/9. Solving. If we have 5x equals 16, what if the base for 5 cannot be the same for 16? Well, graphically we can do this. We can say, let's let y1 be the 5 to the x power, and let's let y2 equal 16. Okay, if we graph this on a graphing calculator, you'll see, well, y2 equals 16, that's just a horizontal line. So we have this horizontal line at 16. Okay, if we graph that 5 to the x, okay, 1 is going to go through 0, 1, okay, this y-intercept, but then as we keep graphing it, you're going to get this exponential model, and this exponential model is going to go up, and there's our exponential model there. Now, if you notice, these two lines intersect. That is the point at which they are equal. So this is some point x comma y. Well, we're interested in x and y value. So if we're trying to solve for x, in this question, we want to find out, well, what's the x value here? So we're trying to find out that x distance. If we did that and we calculated this value, so where is this intersection? You should find out that using the calculator, this is equal to 1.72 comma 16. So y was 16. So therefore, x is approximately 1.72. If we check, going back, well, 5 to the 1.72 should be equal to and 16.008. Okay, so a rounding error. Now the algebra approach, summarizing the steps, we need to take the log of both sides. Okay? And then we're going to use this power property to pull down the exponent, and then we're going to solve for x. So if we start off with 5 to the x equals 16, we know that we can use the log property and write log base 10, 5 to the x equals log 16, or base 10. Okay, we're going to take this x, we're going to move it in front, so now we have x log base 10, 5 equals still log 16 base 10. Now if we need to solve for this x, we're going to divide by log 5, and we get x equals log 16 over log of 5, which in your calculator is approximately 1.723, which matches just about that answer over there. So using what we just found, we're going to solve algebraically using logs. We need to make sure we isolate the base and the exponent, and then make sure we take the log of both sides. Okay, I'm going to start with number 2 and then let you do 1 and 3. Notice it's an exponential. We have 729 and 8. So let's go ahead and take the log of both sides. So log base 10, 8, 2x minus 1 equals log of 729. Now this exponent will shift in front. So we pulled that down. So we have 2x minus 1 in front. We have log 8 equals log 729. We're going to divide by log of 8 to isolate the x. So divide by log of 8. So we get 2x minus 1 should be equal to whatever log of 729 divided by log of 8 is. If we're still solving for the x, we need to subtract 1, which means we'll subtract 1 over here. So 2x equals log 729 divided by log of 8 minus 1. And then the last step is to divide this whole thing by 2. So we'll go x equals, take a half of the log 729 divided by log of 8, then minus the 1. If you notice, go back up. Okay, this is going to be plus 1, so this will be plus 1. Okay, this is approximately, in your calculator, 2.085. Rounded to 3 decimals there. Okay, go ahead and hit pause. Do number 1 and 3. We'll see you back here in a couple minutes. Welcome back. By using those properties of logs, bringing down the x, dividing by log of base 3, you should get about 0.631. And on 3, make sure we divided by 2 first, then logged both of them to base 10. You should get about 3.969. By looking at these, what we should notice is maybe some shortcuts, or in this case, what we call the change of base formula. In other words, if we don't have the same bases, can we change them to base 10? Okay, so we need to, again, convert to exponential form. So if we have 8 to the x equals 97, if we notice that these are not the same, or we cannot make them the same bases, we just did it. We log both sides. 8x equals log 97. We're going to end up dividing by this log of 8. So we have log 97 divided by a log of 8, which is approximately 2.200. In this case, if we take just straight variables, we're going to make b to the x equals a. If we log both sides, x is going to equal the log of a divided by the log of b. That is our change of base formula. So we have log of ba is really equal to log of a over log of b with base 10. Okay, or we can look at it as ln of a over the ln of b. Big note, base, whatever the base is, that's the bottom. So take the log of that bottom base. Some problems, we're going to use the change of base formula to evaluate. One thing we can do is we can change sometimes bases to different numbers. If we're going to say rewrite log 927 in base 3, that means that we're going to take and rewrite this exponentially. We know it's 9 to the x equals 27. So this is really log x equals log 27 over log of 9. But if we change them to base 3, this ends up being log base 3 27 over log base 3 9, which another way of writing this, if we write it over here, is log base 3 3 to the third over log base 3 3 squared. If you remember, the exponents come out. Log base 3 is equal to 1. So your answer is 3/2. If we're going to evaluate this one, okay, with our calculator, well, we need to change a base. Well, we know base is 6, so log 6 on the bottom, log 0.32 on top. 0.32 divided by that log of 6 gives us approximately negative 0.636. Alright, last solving. Check your answers. We need to rewrite each one of these logs when we're solving as one log. Note, the domain y equals log base bx is the domain that x is greater than 0. Meaning, when we solve for x, you cannot take logs of negative. So if we do have negative answers, chances are it's going to be a no solution. So let's do 1 and 3. We need to rewrite these as single logs and then solve and so forth. So for instance, on the left hand side, if we notice the plus signifies multiplication. So I know that this is log base b 5 times x minus 3 equals log base b 2x minus 3. Okay. Well, if these are supposed to be equivalents and the base b are there, then I know that these two answers underlined in green, those two answers need to be equal to. So if I just simply set those equal to each other and say 5 times x minus 3 should be equal to 2x minus 3, now we can solve. So we get 5x minus 15 equals 2x minus 3. Subtract 2x, add 15, we end up getting 3x equals 12. So x equals 4. If you do substitute back in, notice we get log base b 5 plus log base b 4 minus 3, which is 1. 5 times 1 is 5. So on the left-hand side, we have log base b 5. If we plug in 4, we get 8. 8 minus 3 is 5, so we also have log base b 5 on the right. 3, if we combine logs, okay, the plus again signifies multiplication. So property says that we can multiply x times x minus 2, set that equal to 3. Notice we have a log on the left and nothing on the right. Or technically we have just a 3, so we don't have another log. So that's what we're used to seeing. So if we have one log set equal to some number or a variable, let's rewrite it exponentially. So exponentially the base is 2. 2 to the power of 3. And then that should equal our answer, x times x minus 2. By simplifying, we have 8 equals x squared minus 2x. Notice what you have. Ding, 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 ding. You have a quadratic. Move everything to one side. X squared minus 2x minus 8. Okay. We can hopefully factor that down and make it easier. 0 equals x minus 4, x plus 2. So answer is going to be x minus 4 equals 0. X plus 2 equals 0. X should equal 4. X should equal negative 2. Remember though, when we plug these back in, we can't get any negative answers. So if we plug in 4, you get log base 2 4 plus log base 2 2 equals 3. 2 to the second equals 4. So this is 2. Log base 2, 2 is 1. 2 plus 1 is 3. That works out. If you notice that we take this negative 2, as soon as we take the negative 2 and we plug it in this side, we're going to get log base 2 to the negative, or log base 2 negative 4. You can't have a negative 4 for an answer here for the log. So this one does not work, and the answer is just 4. Go ahead, hit pause. Do 2 and 4. I'll see you back here in a couple minutes. Welcome back. If you look at number 2, we need to combine the first two logs on the left, and that's where the log of 5, 3 minus t divided by t squared come from, equals log base 5, 2. Since both log base 5s, we need to set those answers equal to each other. So we end up getting what's called a proportion, if you remember. How do we solve proportions? You need to cross multiply. So we cross multiply and notice we get another quadratic. Move that to one side. Use the formula. Hopefully you can factor. I factored. We got two answers, negative 3/2 and 1. If you note, the negative 3/2 goes in there to the t and you get a negative log. Cannot do that. So the answer is just t equals 1. Okay, for 4, we have the 2 logs on the left-hand side. Combine them with the division. We get log base 3 x squared minus 4 divided by x equals 1. Notice you have one log. Rewrite it as an exponential equation. So the answer is base 3 to the first equals x squared minus 4 divided by x. Now again, make the 3 a fraction, 3 over 1, cross multiply, get another quadratic. Your answer ends up being 4 and negative 1. The negative 1 makes a negative log, so the answer is 4. Remember, do your best, forget the rest. Bye for now.